Welcome to another video lecture, folks. This is your introduction to Chapter 8, which is regarding exponential functions and logarithmic functions. These are two brand new functions for us, and we're going to see what they do in this section and in the sections to come. So first of all, I want to preview a little vocabulary. We're going to see terms like exponential growth. We're going to see exponential decay. We're going to see what a horizontal asymptote is. The best way to show you that is to look at the graph. So we'll see that in the graph. Also, we're going to talk about the growth rates, although we won't see that term today. And if you notice, this new word here, which I know you have not seen before, logarithmic, is definitely off this list of vocabulary because we're not going to see that way till Chapter 4. So it's going to become a very important topic for us. Half the chapter is about logarithmic functions. But right now, I'm going to leave that off our vocabulary list. We're going to see that at a later date. So let's take a look at our objectives for these first two sections. I'm going to wrap these together, exponential growth and exponential decay. So after this lesson, you should be able to graph at least one exponential growth function. We're going to do that together. We're also going to graph at least one exponential decay function. So we're going to have growth and we're going to have decay. Think about what those words mean. Think about what the difference is between growth and decay. So when we see those in the graphs, hopefully they make some kind of sense. I'll leave that up to you guys to think about that. Okay. Lastly, we're going to model at least two real-life applications. I'm not going to do that in this video. So I'm going to put a little star here that I'm actually not going to do that right here, but that is part of the section eventually. So what you're going to need at this point, and you might want to pause it right after I say the sentence, is you're going to need some graph paper. We're going to make two graphs, but you should definitely have some graph paper. So you might want to grab that now and then come back and then get this video going again. Okay, so let's start off with the basic form for the form for a basic exponential function is f of x equals ab to the x, right here. Okay, we can also write this as y equals ab to the x. So brand new function, right? We haven't seen anything like this before. Perhaps you saw this back in Algebra 1, but it's been a little while, right? B, this is called the base, right? It happens to be b for base, which works out nicely. But it's the base for the exponent, right? X's are exponents. And if you notice, this is why we call this an exponential function. Where is the variable? Where is our input? Our input's in the exponent, right? Here's our input, right? Way up in the exponent. So that's why we call it an exponential function. Okay, so in this section, we're going to investigate exponential functions. Our base is always going to be positive. We're not going to have a negative base. Weird things start to happen if you have a negative base. So if you keep that in mind, that might help things out a little bit. Okay, so here, hopefully you have your graph paper. We're going to go ahead and graph y equals 2 to the x. In fact, what I'm going to do is I'm going to call it just that, y equals, and I'm going to rename this, I know this looks kind of weird, 1 times 2 to the x. This will make sense hopefully by the end of this video, but I want to just let you know that we're multiplying by 1 out there. Okay, so what I'm going to do is I'm going to make a little table. So I'm going to start with 0, right? That's the first input I'm going to look at. And I'm going to go right a couple units, 1, 2, and 3, and then I'm going to go left a couple units. And that's really all I need to get a look at what this graph is doing. So the first thing I'm doing is I'm going to put in 0. Okay, so what's 1 times 2 to the 0? Or just 2 to the 0 is 1, right? So the point 0, 1 is going to be on a graph. So here it is right here, right? You just have the PowerPoint presentation, put the little dot there for me. Okay, and I'm just going to move down the list here. What's 2 to the 1? Well, that's 2, right? Okay, so 1, 2 is going to be on the graph. And then I'm going to do 2 squared. 2 squared is 4. So 2, 4 is on the graph. Likewise, 2 to the third is 8. So 3, 8 is going to be on the graph. And here's all those points there. So what I want to take a moment here to look at is what did we do to get the next point? Well, the first point had a height of 1. The next point, I doubled the height, right? I multiplied it by 2. That's why it's 2 to the x. And then I doubled the height again, and now the height is 4. And then I doubled the height again, and now the height is 8. So hopefully you're making that connection, and that's a really important aspect of an exponential function. So what should happen when I work to the left? Well, let's start off with our height of 8 here in blue. And if I take half of that, my next height should be height of half of 8. Well, that's 4. Half of 4 is 2. Half of 2 is 1. Well, what's half of 1? Well, that's a half, right? So my next point here, this has a height of a half. And if I check over by my table, if I do 2 to the negative 1, well, 2 to the 1 is 2, and I take the reciprocal because it's a negative exponent, so that height is going to be a half. And likewise, half of the half is going to be a quarter. So it's going to go down just a little bit, right? It's going to get closer to that x-axis. And I can take half of a quarter and I get an eighth, right? This is 2 to the negative 2 here, right? 2 to the negative 3, that's an eighth. So I get halfway closer to that x-axis. I'm going to get all this stuff out of the way, of course. Make a little room. And now what I'm going to do, and this would carry on, right? I can go half that height, half that height. I can keep going way out there. So what I'm going to do here is I'm just going to have the computer here draw this nice smooth curve. This is a new parent function for us. This is a new look. Just like you know what a parabola looks like, you know what a line looks like, we know what a cubic function looks like, all these other functions. This is a brand new function. We want to memorize what this thing looks like. So let's talk about what the end behavior is. Well, and I need to get this stuff out of my way. So I'm going to put up the frame here for our end behavior that we have so far. We look at what's happening as x goes way to the left, what's our function doing, and then what's happening as x goes way to the right. So, well, what happens? Well, our function gets closer and closer to the x-axis, right? I keep taking a half and a half and a half. Well, it's getting closer and closer to 0, right? Isn't our y value just getting closer to 0? It's no longer going just to negative or positive infinity. You've got to really look at the graph and see what it's getting closer and closer to. Well, it's getting closer and closer to 0 as we go out to the left. Okay, what about as we go out to the right? Well, let's look at our points here. They're going up and up and up. Those are actually going to positive infinity. So it can go to positive infinity, but it doesn't have to, right? Again, take a look at the graph, see what your y values are doing. Okay, I want to go back to the idea. I'm going to look back at these red dots again. I'm going to erase this for a second. Look back at these red dots. And remember how I said that these are getting closer and closer and closer to that x-axis? That's called a horizontal asymptote. In this case, y equals 0 is or the x-axis is what we call a horizontal asymptote. It's the horizontal line that our function is getting closer and closer to as we go way out to the side here. As I go way out this way, right, our function is getting closer and closer to that x-axis. That's what we mean by a horizontal asymptote. There's a technical definition for it. I'm gonna save you guys from that from now, at least in the video. But hopefully the visual makes some sense of what a horizontal asymptote is. Okay. So that was our, let me go back for a second here. That's our exponential growth function. Again, it's growing, right, as we go up to the right. Okay, so we're going to graph a horizontal, an exponential decay function, and we're going to see exactly what this looks like. So I'm going to get a very similar setup here as far as there's my graph, there's my function. I'm going to do the same thing with the table. I'm going to put in 0 into the function, 1, 2, and so on, and let's see what we get. Okay, so I'm going to do 1/2 to the 0. Well, what's anything to the 0 power? Well, it's 1, right? Okay, well, what's 1/2 to the 1? Well, that's just itself. That's going to be a half. Okay, well, what about 1/2? Oh, and I should probably put my points up here. There's 1/2 to the 0, right? Output is 1. 1/2 to the 1, there's the output. 1/2 squared, well, that's saying take 1 squared, take 2 squared, I get 1/4, right? So if you notice what's happening here, hopefully you see in just the first 3 dots here, I'm multiplying by half each time, right? So my y values here are getting closer and closer to that x-axis, right? So my next point is going to be 1/2 to the 3rd, or 1/8, and it's going to keep on going down. I'm going to have this horizontal asymptote again as I go out to the right this time, right? This is exponential decay. This is going down as we go to the right. Okay, so well, what happens as we go to the left? Well, I'm going to give it away here. It's going to go up just like it went up as we went to the right in the last function here, right? So if I do 1/2 to the -1, well, again, that means reciprocal of a half. Well, that's 2, right? So if I work back to the right, I'm going to double my y values, right? That's a y value of 1. I'm going to double that. Now that's a y value of 2. Well, if I double that again, I'm going to get a y value of, guess what? 4, right? So there's my output right there. There's my y value of 4. Oops, I think I went a little too high that time. Okay. So anyways, 1/2 to the -2. Again, that means reciprocal, and then square it. So 2 squared is going to give me 4. And again, if I double that again, I'm going to get an output of 8. So 1/2 to the -3, that's 8. And again, there's all the points. I'm going to connect them with a nice smooth curve. And it should look awfully familiar, right? It looks a lot like the exponential growth function, but it's flipped the other way around, right? It's flipped over the y-axis. So instead of going up to the right, it's going down to the right. Well, we can still talk about the end behavior, right? So you guys try this one on your own. Here's the format. You guys fill this in. So what happens as we go to the left? Well, as we go to the left, this function is going way up to infinity. Okay? So f of x is going to infinity. Well, what happens as x goes to the right? Remember, positive infinity is out to the right. Well, this is going down. Well, it's not going all the way down to negative infinity. It's getting closer and closer to 0, right? We have that horizontal asymptote again. There you go. I started writing it, and then I realized I actually made it on the screen, didn't I? Okay. So we're getting that horizontal asymptote again. And notice how that horizontal asymptote, y equals 0, that's the same as the end behavior, isn't it? Because that's what it means. As we go way out to the sides, what's our function going closer and closer to? That's our horizontal asymptote. That's our end behavior. Okay, so we're going to leave the graph for a second here. Actually, we're going to be done with the graph now. And we're going to move on to the next little bit as soon as I can see what's going on my screen. And, oh, nice. They got all this stuff in the way. Great. Okay, and I want to go to this screen here. No, this has gone way too far. Okay, so some things to notice. So up here, here's our basic form for a simple exponential growth or decay function, right? This could be growth or it can be decay, right? I just changed what happened with b. Okay, so notice that, and this is why I wrote this before as y equals 1 times 2 to the x. It went through the point 0, 1. It went through whatever this essentially is our y-intercept. This is our initial value. Those are the same thing. Initial value, y-intercept are the same thing. So that's why I was trying to point out before that the coefficient there should be 1, because that was the y-intercept that it had gone through. Okay, something else of note is that the x-axis is the horizontal asymptote. Again, there's that new word that I talked about earlier today, that horizontal asymptote. No matter what the function is, no matter what my base is, or no matter what I make this leading coefficient, the x-axis will be the horizontal asymptote. Eventually, we will shift this thing up and down and left and right, and that will change. But for the simple form, that's our horizontal asymptote. Okay, I left this blank for a second here. What is the domain? Go look at what we said before, or look at the graph. What x values are used? Well, all x values get used. So the domain is all real numbers. Okay, and what about the range? Well, what y values got used? Well, we didn't get anything below the y-axis, did we? Excuse me, the x-axis, right? Everything, in fact, we didn't get down to 0. We got close to it, but we didn't get exactly down to 0. So everything stayed positive. So everything's going to be positive if that leading coefficient is positive. Otherwise, if A is negative, we're going to see that sometimes we get outputs that are negative. That's not, we're going to see that more in the graph. That's not something to memorize. The domain is something you should probably memorize, which is all real numbers. But this range part here, this is going to be something that we do by looking at the graph, not by memorizing it like on this list. Okay, so question for you folks here. What was the difference between our exponential growth and our exponential decay function? Not the graph, but what caused us to have an exponential decay instead of exponential growth? So remember our two functions that we had. We had y equals 1 times 2 to the x, and we had y equals 1 times 1/2 to the x, right? So what's the difference? What is it about 2 that makes it growth and 1/2 make it decay? Well, hopefully you see that 2 is greater than 1, right? If we keep multiplying by 2, it's going to grow and grow and grow, right? As opposed to multiplying by half, it's going to get smaller and smaller and smaller. It's going to decay, right? If we keep multiplying by half. So that's the main thing. We want to look at what our base is doing, right? Base greater than 1, we're going to get growth. Base less than 1, we're going to get decay. I'm going to break that rule, by the way. I hate to say that, but I'm going to break that rule in the third problem here. I'm kind of giving it away, but I just want to let you know that that's going to happen here. This is a pretty darn good rule to live by here, for the most part. Okay, so let's take a look at a couple problems here. Let's state whether or not our function is exponential growth or decay. We're also going to state the initial value, just for a little practice here. Okay, so what do you folks think? Y equals 5 times 2/3 to the x. Is this going to be growth or decay? Well, again, we said it's all in the base, right? That base is less than 1. This is decay. Hopefully that's what you thought. Okay. What about the initial value? Well, the initial value is just hanging out here. That's all it is. It's 5. So our initial value is going to be 5. And that's how easy it is to get that initial value. If you don't like that, if you don't like looking at that and just picking out 5, I don't know why you wouldn't, but I guess that would be an issue maybe. You can put in 0 for x and do 2/3 to the 0 is 1, and then 1 times 5 is 5. You can do it like that if you want, but that's a little extra work in my book. Okay. What about this one? What about y equals 6 times 5/2 to the x? Well, again, look at that base. Is that bigger or less than 1? Well, it's bigger than 1. It's got to be growth. So here we have a growth problem. And what about the initial value? Well, again, just hanging out here, the initial value is going to be 6. Okay, here comes the curveball. Remember, I said I was going to break the rule. So here comes the curveball. What is it? Why am I breaking the rule here? Well, you look at this and you say, okay, that base is greater than 1, so it looks like it's growth. Can you tell me why it's not growth? Here's a hint for you. Can you see why it's growth now? Well, what does a negative exponent tell you to do? Well, it means reciprocal of the base. So this really is saying y equals 10 times 1/3 to the x. Right? Isn't that what that negative exponent means? Unfortunately, it does. So it makes it look really unusual, right? We tend not to write, sometimes we do, but when I'm giving you practice problems, we're not going to see too many of these, or like on assessments, but they do pop up. So really, this is decay. This is kind of a curveball here. This one's decay, because that base really is 1/3. When we get it back into our nice form, right? We want it as y equals ab to the positive x, right? Not ab to the negative x. Okay, so last thing here, what's the initial value? Well, the initial value is the value that's just hanging out here, right? That's just going to be 10. Okay, so did we do what we said we were going to do today? Again, we said we weren't going to do these real-life problems till later here. So did we graph at least one exponential growth function? Yeah, well, we did exactly one, right? So we did hit that mark. Did we look at and graph at least one exponential decay function? We did that, okay. So do you have kind of a grasp of what's going on with these exponential growth and decay functions? Hopefully this was a nice little introduction. We're going to play around with these quite a bit more in class in the coming days. So take care and have a good one.